Good morning everyone. Now let us perform the same in the online simulator and see how exactly the values are getting changed. So this is the online simulator. This is just a set of random instructions I gave using shifting and rotation along with other instructions. So I went to the memory and then entered the value DABCDEF1. This is a random value I gave in the location 1 followed by 7 zeros. So let us compile and load and see whether there are no errors. So the compile is succeeded, there are no errors. So now the first line corresponding to this is where the cursor is the cursor is waiting for execution in the disassembly window. Now let us do line by line. So the first line corresponds to loading R0 with the value 1 followed by 7 zeros and then loading R11 with that value pointed by the address, this one. So in 1 followed by 7 zeros we have DABC DEF1. So the R11 will be loaded with that value. So let me just show that. So now R11 is having DABCDEF1. Now let us see the next command instruction. Move R12, R11, LSL #1. So let's see how the value in R12 changes. So logical shift left by 1 bit to the left. That is what we are supposed to do. So please do that in your notebook so that you will be able to understand. Then we can cross verify the answer. So if you see, this is the value, this is the binary corresponding to DABCDEF1, and when you left shift and then take the value, it should be equivalent to B579BDE2. So let us see whether it works. So in this, when we do it, so B579BDE2. So that is the value that is coming to this R12. So in the disassembly window, if you see, that is coming for this instruction, move R12, R11, LSL, #1. Now let's see what happens when move as R12, R11, LSL #1 when we do that. So when we do that, this leftmost bit, since we are giving a S along with the corresponding mnemonic, so the flag will be affected. So this LSL #1, again R11 will be left shifted by 1 bit to the left, and the corresponding bit from the left will go to the carry flag. So if you see, in R11 we have the leftmost nibble corresponding to D, which is 1101. So this leftmost one will go to the carry flag. Now if you see here, we have the negative flag, zero flag, carry flag and overflow flag. Those are the main user flags we will be working with. In this, the carry, it's disabled now. When we execute this instruction, that should become 1. So if you see, the carry has become 1. And this corresponding value in R12 also got changed according to the left shift. So the value is B579BDE2. So it became that, and the carry flag also got affected. This negative flag corresponds to the leftmost 31st bit of that corresponding register. If it's equal to 1, that means it is negative. If it is equal to 0, that means it is positive. So for signed numbers is where we will be using that negative flag. So in R12 we have the leftmost nibble corresponding to 1011. That is why the negative flag is 1, because the leftmost bit is 1. Now let us see when we do move as R2, #0, what happens. So this corresponds to R2 becoming 0, and then we have said that the flags also need to be affected. So that in the disassembly window, that is what it is going to happen. So 0 flag gets affected. So I wrongly gave here as clearing carry flag. It is not that. We are setting the 0 flag, showing that. So setting the 0 flag. So that is what it happens. The carry flag remains in the previous corresponding value. The previous value was 1, so it remained there. No change in the carry flag. Now if we do LSRS R2, #1, the rightmost bit in R2, R2 will get right shifted to 1. So this R2 we haven't loaded any value, so I will change this to R12. So the rightmost value in this the rightmost bit in R12 will get right shifted, and R2 will become that value. So the value in R12 that will get right shifted by 1 bit to the right and R2 will be loaded with that. And since the rightmost nibble is 2, which is 0010, carry flag will be cleared. So if you see here, the carry flag has been cleared. 0 flag, it's also not set because the answer is not 0. Now if you look at R2, this is the value, you can check that. So this also got executed. Now if you see the rest of the commands, it is the same. The next command corresponds to move R12, R11, so let us see. So it is move R12, R11, LSR #1. So which corresponds to logical shift right. So what exactly happens in this? In this what happens is, R11 will be logical shift righted by 1 bit to the right and R12 will be loaded with that value. Here the difference only is this will affect the flags. So all the flags will be affected and see the effect. When you are doing that, see the effect in carry and 0 flag. Now LSRS R2, R2, #1. I am not mentioning this comment. This may not be the correct comment. So you can see the value what exactly happens. Now comes the rotation instructions. Okay. So let me just go till that instruction ROR. So let me go to disassembly and I am going till ROR. Now ROR R10, ROR R10, R12, #1. So what is the value in R12? 6D5, E6, F7, 8. So all these values you have to cross check in your notebook whether it is coming correctly. Then only you should verify in the simulator. Now in ROR what happens is, this was the value that is coming in this one. Which one? R12. R12 was 6D5E, 6F7, 8. So now in this ROR what happens is, the rightmost bit will be rotated. So this 0 comes in the leftmost position and rest of the bits will be right shifted. So this comes here 0, this comes here 0, 1, 1, then 0, 1, 1, 0 and so on and so forth. So we should get the answer as 36AF, 37BC. So let us see whether we are getting that answer in R10. So 36AF, 37BC, that is the answer we are getting in R10. Now RORS what will do, the only difference in RORS what will do is, the rightmost bit, this R12, the rightmost bit will come to the leftmost bit, but it will also go to the carry flag. That is what it is going to happen. So you need to see that how exactly this RORS works and then check in your notebook and see the answer whether it is coming. Then the rest of the this could be this logical shift left and the rotations also you could add along with other instructions. So if you look at this instruction, add R9, R9, R10, ROR #2. What this does is, this R10 will be right rotated by 2 bits and then it will be added to R9 and R9 will be replaced with that value. So this corresponds to the instruction R9 equals, so R9 equals R9 plus the R10 right shifted by 2 bits. That is what will happen. Now in this move R9, R10, ROR #1, this R10 will be right rotated by 1 bit and then it will be loaded to R9. You may check the corresponding values in the simulator and then work it out. Thank you.